Hey guys, welcome to the new video. In the previous videos we have discussed about the number system and the conversions. Today we are going to discuss about the Boolean algebra. The Boolean algebra is an algebra which manipulates on the logical values. Logical values means either true or false. Here comes the word logical. Actually logical statement means any of the statement which can violated be either true or false values, that is known as logical statement. I am taking an example. If Ram is a good boy, the answer can violated be either true if Ram is a good boy, or it can be false if Ram is not a good boy. So logical statement is a statement which is violated either in the true or false value. The Boolean algebra manipulates on that logical statement. In the Boolean algebra, the truth value is denoted as 1 and the false value is denoted as 0. The Boolean operations of Boolean algebra can be of three types. One is AND, which is known as conjunction. The second one is OR, which is known as disjunction. And the third one is NOT, which is known as negation. Apart from these three, we are also getting two more operations, which is known as NAND, which is a combination of NOT and AND. And both. The second one is NOR, which is a combination of NOT and OR. Now I will show you what are the logic tables for that and what are the logic gates for that. Coming to the AND gate. As I said, it is known as the conjunction. This is the symbol of conjunction, and in the Boolean algebra, this is denoted as the dot operator. So I can say that A and B means A dot B. The simplest way to remember the AND gate is when both of the statements are true, only then the violated answer will be true, otherwise false. I am repeating it again. The simplest thing is when both of the statements or when all of the statements, it can be true, it can be two, it can be many. When all of those statements contains true value, that means if they contain one, and as much as statements are there, if they all contain 1, then the violated answer will be 1, otherwise it will be 0. Here you can see if the value of A is 1, that means true, and the value of B is 0, that means false, then the violated AND gate is false. If 0 and 1, then also it is false. If it is 0 and 0, it is also false. Only when both the statements are true, then only the violated answer is true. You can clearly see I have written that when both the statements are true, then only the A dot B is true, otherwise false. That means to get the value true, all of those possible values must be true. Here you can see the gate. A is here, B is here. I have created an AND gate over that, and I have got the output as A dot B. Similarly to the OR gate, which is known as the disjunction, it is denoted as the plus operator in OR gate. This is just the vice versa of AND gate. That means in the AND gate, only when both the statements are true, only then the violated answer is true. So thus the negation of that means only when both the statements are false, then only the answer is false. In all of the above, the answer will be true. Here you can see 1 0 1 0 1 1 1 1 1 and only 0 0 equal to 0. I have written that when both statements are false, then only the A plus B is false. Otherwise, it is true. Only when all of those aspects statements are false, then only the answer is false. Otherwise, in every situation, the answer will be true. It is the OR gate. You can see A, B, it is just a curve, and I have joined it, and it is A plus B. Now coming to the last one, basic operation of Boolean algebra, which is known as NOT gate. This is otherwise also known as inverter gate, and also it is known as the negation. Negation means opposite. That means it gives the value opposite of the given input. That means if the input is 1, then it will provide the answer as 0. If the input is 0, it will provide the answer as 1. It is denoted as a tied symbol. Here you can see A dash means the tied A. If the given input is 0, then the tied A will be 1. If the given input A is 1, then the tied of A will 0. It gives just the opposite of the given input. That is, if the input is 0, then the output is 1, and the vice versa. You can clearly see the NOT gate. A, I have created a simple triangle and a dot, and it will provide the tied A. To the NAND gate, which is the combination of NOT plus AND. So
here the inputs are A, inputs are B. Then I have to create an AND gate for that. The AND gate will be illustrated as A dot B. Now the NOT of that means A dot B hold as. This will be the NAND gate. That means 1 0 0 1 0 0 1 1. In the AND gate, only when both the statements are true, then only the answer is true, otherwise false. So I have to print it 0 0 0. Now coming to the this section, I have to get the A dot B dash. That means I have to change the 0 to 1 and 1 to 0. So here is 0, 1, 0, 1, 0, 1 and 1 is 0. This is the respective NAND gate. Similarly, I can create a NOR gate for that, which is a combination of NOT plus OR gate. Similarly, here is A input, here is B input, here it is the A plus B, and for NOT I will create A dot B hold as. That means 1 0 0 1 0 0 1 1. In this case, only when both the statements are false, then only the answer is false, otherwise it was true. It is just opposite that. I will substitute 1 to 0 and 0 to 1. 1 0 1 0 0 1 1 0. This is the respective truth table for NAND and NOT gate. Now I am going to illustrate an example. You have to draw a logic gate for this. So the question is xy plus x dash y. So you can get this x and y, in between there is a dot. That means it is a AND gate. And x dash y, it is also a AND gate. And in both these two there is an OR gate. How to do that? First, create an x, create an y. This is two inputs for that. Now you have to create a AND gate in between that. Just create a AND gate. You will get the answer, which is known as xy. Now you have x, you have y. Now you have to get x dash. So you have to put a inverter gate on the x. Now what you will get is x dash. Now the y will be simple, and in between that you have to create another AND gate. Now here you will get x dash y. You got xy, you got x dash y, and in between that you have to create an OR gate. Just hold it, a curve, a curve, a curve, and this is the desired output. So you have to create a logic gate for this.
This is all about the 5 Boolean operations. Rather than this, there is another two, which is known as exclusive OR and exclusive NOR, which we will discuss in the further video. I hope I am getting very understandable to all of you. I am using very simple language for this, and please, if you like it, do like, do subscribe.